I'm Anil Kumar. Welcome to my YouTube channel and also to this Global Math Institute website, which we are developing to provide you with organized set of videos. We'll talk about solving quadratic equations, and I've taken up 24 examples where we'll factor and then find the solution. You can always pause the video, answer these questions, and then look into my suggestions. So let's begin with the first set of three trinomials to factor. So we have x squared plus x minus 12 equals to 0, x squared plus x minus 6 equals to 0, and x squared minus 5x plus 6 equals to 0. In these three equations, you observe that the coefficient of x squared, the leading coefficient, is 1. And so we can factor this using product and sum, right? So the strategy is product and sum. Let us see how to apply this strategy. So we have x squared plus x minus 12 we're looking for two numbers, let us say p and q, whose product is minus 12, and sum of these two numbers is 1, the coefficient of x. Well, the two numbers could be 4 and 3. Since we need positive sum, 4 will be positive, 3 will be negative. And therefore, we can write down the given trinomial as x plus 4 times x minus 3, right? If you find this difficult, then you have to look into the previous section where we are focused more on factoring, right? Now here we are focusing on solving a quadratic equation by factoring. So once you factor, we need left hand side to be equal to 0. That is possible if these factors are 0, right? So we'll solve it by saying, well, that means x plus 4 equals to 0, or x is equal to minus 4, or x minus 3 equals to 0, or x equals to 3. So we have two solutions to this. The solutions are x equals to minus 4 and 3. Okay? So that is the way that we are going to solve all these equations. So it is once again practice on factoring, which we learned in the previous unit, and we are going to apply this in the coming unit for solving application problems. You can now pause the video and answer these questions. Let's continue. So now we have x squared plus x minus 6 equal to 0. We're looking for a product of two numbers that should be equal to minus 6, and the sum should be equal to plus 1. Well, 3 times 2, 3 positive, 2 negative. So you can write this as x plus 3 times x minus 2 equals to 0, and that gives you x equals to minus 3, and this gives you x equals to 2 as your solution. Perfect. So I hope you find it simple, right? The last one on this page is x squared minus 5x plus 6 equals to 0. Again, product and sum. Product should be 6 and sum should be minus 5. So the two numbers could be minus 6. No, it should be minus 3 and minus 2. So when you add them up, you get minus 5. When you multiply, you get plus 6. So that is kind of important to understand. So we get x minus 3 times x minus 2 equals to 0. That means x is equal to 3 or x equals to 2. Perfect. So let's continue and take up the next set of three questions now. We have x squared plus 7x plus 10 equals to 0. We're looking for two numbers, p and q, whose product should be equal to 10, and the sum of these two numbers should be 7. Well, 5 and 2 can work for us, right? So we could write this as x plus 5 times x plus 2 equals to 0. That means x is equal to minus 5 or x is equals to minus 2. Now we have x squared minus 15x plus 56 equals to 0. We're looking for again two numbers whose product should be 56 and sum minus 15. 7 times 8 is 56. Both should be negative to get a negative 15 as their sum. So we have this as x minus 7 times x minus 8 equals to 0. That gives you x equals to 7 and x equals to 8. So it again has two solutions. Now we have x squared plus 2x plus 1 equals to 0. 1 times 1 is 1, and when you add it, you again get 2. So we can straight away write x plus 1 equals to 0, which is x plus 1 whole square. Now in this case, you observe that x equals to minus 1 is the only solution, right? Now this kind of a trinomial is also called a perfect square, right? What you observe here is that the form is a square plus 2ab plus b square. So let me write down. If you have a plus b whole square, and it can be written as a square plus 2ab plus b square. It could be a minus b whole square. In that case, the center term will be minus. So in such cases, we are going to have only one solution, just as you saw it in this example. The next set is, now we have all negative numbers, which is minus x squared minus 6x minus 9 equals to 0. You can always take minus common, right? So you write this as 6x plus 9 equals to 0. Right? You could drop this minus and just take x squared plus 6x plus 9 equals to 0. Now here also you observe that 9 is a square of 3. And the center term is 2 times 3, right? So this is a perfect square where you could think about it like this, written as in this form, correct? So you could factor this as x plus 3 whole square. It is kind of important to identify perfect squares, right? So learn to identify perfect squares. That is also a skill, right? You could have done otherwise also. 3 and 3, those are the two numbers which when multiplied gives you 9, and when you add them gives you 6. So as such also you expect a perfect square, correct? Now we have x squared plus 10x plus 25 equals to 0. 25 is 5 squared and 5 plus 5 is 10, right? So let's do it with product and sum this time, right? So we're looking for product to be 25 and we're looking for the sum to be 10. The two numbers are 5 and 5. Do you see that's exactly same? So we get x plus 5 times x plus 5 equals to 0. And that is same as writing x plus 5 whole square equals to 0, or x is equal to minus 5. Do you see that? So if you recognize that this is a perfect square, we can straight away write down the answer. Correct? Just as in this particular case, we have x squared minus 8x plus 16. You can see that we can write 16 as 4 square, right? Here we already have x squared. The center term is 2 times 4 times x. That is how you get 8, right? Equals to 0. So we could write this as x minus 4 whole square equals to 0. Perfect. So you take minus from here and 4 from this side. And that way you actually save some time, right? So x equals to 4 is the only solution. Is that clear to you, right? So identifying perfect square is also important in solving such equations. Now we have x squared minus 1 equal to 0. Well, this is difference of square, right? So let me write down here difference of square. Now here, if you have a square minus b square, you could factor this as a plus b times a minus b. That's the whole idea, right? So let's factor x minus 1 equals to 0. So we could write this as x plus 1 times x minus 1 equals to 0. That means x equals to minus 1 or x equals to plus 1 are the two solutions. So we could write x as plus minus 1, right? Well, some of you can also factor like this. We are given x squared minus 1 equal to 0. We can take 1 to the right side, and so x is square root of 1. Whenever you do square root, you have to write plus and minus, so you get plus minus 1 as your solution. So that's an alternate way of doing the same thing. However, we'll focus more on the factoring technique as that is general purpose. Now we have 2x squared minus 18 equals to 0. You can factor 2 first. So we get x squared minus 9 equals to 0. 9 is 3 squared, right? So we could write this as x squared minus 3 squared. Think like this, which is same as x plus 3 times x minus 3 equals to 0. And we get two solutions, x equals to minus 3 or x equals to plus 3, right? So x equals to plus minus 3 is our solution. Next question here is 9x squared minus 4 equals to 0. 9x squared is 3x whole square, and that is 2 square. So again, this is difference of square, and we could factor this as 3x plus 2 times 3x minus 2 equals to 0. Now, if 3x plus 2 equals to 0, then 3x equals to minus 2, or x is equals to minus 2 over 3, right? On the other hand, we have 3x minus 2 equals to 0. That means 3x equals to 2, or x is equals to 2 over 3. So we have two solutions here, and the solutions are that x equals to plus minus 2 over 3. So I hope now this strategy is absolutely clear. I would like you to stop the video and solve these questions yourselves. So let's continue. These are slightly different. We now have x squared equals to x. Now at times you can cancel x and make a mistake, right? So important to note here is not to cancel, right? So what you should do is bring them together, right? And now you factor, so we get x minus 1 equals to 0. So we have two solutions, x equals to 0 and x equals to 1. Do you understand? If you would cancel this, you will not get two solutions. Perfect. Next one, here is 4x squared equals to 2x. So what you should do? Bring them together, right? So we'll write it like this. Now factor. So we have 2x common. We get x minus 1 equals to 0. So 2x equals to 0 means x equals to 0. And on the other hand, x minus 1 equals to 0 means x equals to 1. So we have again two solutions. This one is 3x squared equals to 12x. Bring 12x together. So we have 3x squared minus 12x equals to 0. 3x is common. So we get x minus 4 equals to 0. So we get x equals to 0 and x equals to 4 as our solution. Clear? So that is how you can actually solve such equations. Now, we have some fractions involved, simple questions with a variation. So we have x over 2 equals to 8x squared. Bring them together. We can write this as 0 equals to 8x squared minus x over 2. Well, x over 2 is common, right? So x over 2 is common. So when you take x over 2 common, you get 16x minus 1 equals to 0. So that means x over 2 equals to 0, or x is equal to 0. and the other factor is 16x minus 1 equals to 0. That means x equals to 1 over 16. So we have two solutions, x equals to 0 and x equals to 1 over 16. This time we have 1 over 12 minus 3x squared equals to 0. We can take 1 over 12 common, right? So we can do it in a couple of ways. We could also take 3x squared to the other side. So we can write this as 1 over 12 equals to 3x squared. Dividing by 3, we can write 1 over 36 equal to x squared, and then we have to square root it, right? So 1 over 36 is equal to x. Whenever square root, do plus and minus. So we get plus minus 1 over 6 as the value of x. X over 3 equals to 7x squared. In this case, we will take it to the other side. So if this was a number, that was good strategy. Otherwise, you need to factor it. Is that clear to you, right? So we'll factor x over 3. So when you factor, you multiply 7 by 3 to get 21. X has been factored out. This is just 1. So we get x equals to 0 and x equals to 1 over 21 as the solution. We're almost at the end, just 6 more questions to go. So this is 6x squared minus x minus 1 equals to 0. Now we are working in the form of ax squared plus bx plus c equals to 0, right? Where a is not equal to 1. So in such cases, we do adopt product and sum with a slight difference. So we are again looking for product of 6 times minus 1, which is minus 6. And we're looking for sum of minus 1. So the two numbers which can give us product of minus 6 and sum of 1 are 3 and 2. And therefore, the numbers will be minus 3 and plus 2, correct? So we'll split minus x in terms of these two numbers, right? So see the difference in our strategy now. We have got 6x squared minus 3x plus 2x. That gives you minus x, right? Now we'll do group factoring. So factor 3x from the first two terms. We get 3x, 2x minus 1. And here we already have 2x minus 1. 2x minus 1 is a common factor. We get 3x plus 1. 3x from here and 1 from there. Okay? So these are the two factors. Now, 2x minus 1 equals 0 means x equals to half. And for 3x plus 1 equals to 0, x is equals to minus 1 over 3. And that is how we are going to solve it. So I hope the steps are clear. Let's take the next one, which is 4x squared minus 3x minus 10 equals to 0. So we're looking for two numbers whose product should be 4 times minus 10, which is minus 40. And the sum of the two numbers should be minus 3. So what could be these numbers? Well, 8 and 5 can work for us, right? So 8 and 5, 8 has to be negative, 5 positive. So we'll split minus 3x in terms of 8 and 5. So we have here 4x squared minus 8x plus 5x minus 10 equals to 0. Now 4x is a common factor in the first two terms. So we get x minus 2. And here we have 5, x minus 2 as the other factor. X minus 2 is a common factor. So we get 4x plus 5 equals to 0. So that gives you x minus 2 equals to 0, gives you x equals to 2. And 4x plus 5 equals to 0 means 4x equals to minus 5, or x is equal to minus 5 over 4. So these are the two solutions for the given trinomial, correct? You can actually pause the video and do them yourselves, right? 6x squared plus x minus 2 equals to 0. So what are we looking for? Product to be 6 times minus 2, which is minus 12, and sum equal to 1. So 4 and 3 can work, right? So the two numbers are 4 and 3, 4 positive, 3 negative. So we could write this as 6x squared plus 4x minus 3x minus 2 equals to 0. 2x is common factor, so we get 3x plus 2. And here we can take minus as a common factor. 3x plus 2 equals to 0. So we get 3x plus 2 as one of our factors. The other one is 2x minus 1. So that gives you that 3x plus 2 equals to 0 means x equals to minus 2 over 3. And 2x minus 1 equals to 0 means x equals to half. Is that clear to you? So that is how you can do the trinomials, which has the value of a, the leading coefficient, not equal to 1. Last three examples. So now we have 10x squared plus 19x minus 2 equals to 0. We're looking for product and sum. Product should be minus 2 times 10, which is minus 20, and the sum should be 19. Well, 20 times 1 can work for us, right? So 20 and 1. So we can write this as 10x squared plus 20x minus x minus 2 equals to 0. Factor 10x. So we get x plus 2, right? And minus x plus 2 equals to 0. Now x plus 2 is a common factor. We get 10x minus 1 equals to 0. So x plus 2 equals to 0 means x plus 2 equals to 0. So x equals to minus 2. And then we have 10x minus 1 equals to 0 means x equals to 1 over 10. Perfect? Second last question. 12x squared plus 16x plus 5 equal to 0. So definitely the product should be equal to 12 times 5, which is 60, and the sum is 16. So how can we get that? Well, 6 and 10 can work, right? So we can split 16 as 10 and 6 combination. So 12x squared plus 6x plus 10x plus 5 equal to 0. So here we have 6x common. We get 2x plus 1. In this case, we got 5 common. So we have again 2x plus 1. And that is necessary, right? Otherwise, you cannot take a common factor. So we have 6x plus 5 equal to 0. So that gives you 2x plus 1 equals to 0, gives you x as minus half. And 6x plus 5 equals to 0 gives you x as minus 5 over 6. Correct? The last question here is 4y squared plus 12y plus 9 equals to 0. Well, that seems to be a perfect square. We have 2y whole square plus this is 3 square, right? And the center term is 2 times 3 times 2y, correct? We get 12y. So we could write this as 2y plus 3 whole square equals to 0. So that means we have 2y plus 3 equals to 0, or 2y equals to minus 3, and that gives you y as minus 3y2. So in this case, the last question has only one solution. Perfect. So with this example, we have solved all the 24 questions. So solving equations when you have a factored form is really to master the technique of factoring. In this particular example, we saw all types of factoring, right? Simple factoring where a equals to 1, and then we looked into the cases where a is not equal to 1, correct? And we also had perfect squares. We had some simple equations where you could do a mistake by cancelling x. So in that case, we say do not cancel, right? Now with that in mind, I hope you must have learned, or rather mastered, the technique of solving quadratic equations by factoring. We'll now take up a few more examples, application questions, where equations can be written which can be factored and then solutions could be found. I hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like to subscribe to my videos, that'd be great. Thanks for your time and all the best.